So today we're going to talk about 3D printed, about 3D printed jigs and fixtures and how they can be game changer for the industry, and some of our experiences that we have had, and where we have helped industry in terms of setting up these applications. So before we start, this is one of my favorite photos. This is an art. Basically, this is a 2D sculpture which was basically designed by an artist called Brett Ryder for the Economist newspaper. And this depicts, this shows a person sitting on the chair, having a cup of coffee, and having his normal day, and a computer. He's designing something, and he has a factory on his desktop, and with on-demand manufacturing capability, he's producing automobile parts, tools, and aerospace components. This is a dream of on-demand manufacturing. We all are connected with at Divide by Zero, and I'm sure you all are as well. Somewhere connected with this dream, and that's where we all are here today. So, my name is Swapnil Sansari. I'm CEO and founder of Divide by Zero Technologies. We are one of the largest industrial 3D printer manufacturers in India now, and we're one of the first companies to export these machines into USA, Malaysia, UAE, and UK market. Today we have this, I have this opportunity to, bring some of our applications, some of our case studies, and some of the knowledge, humble knowledge that we have gained through support from our customers, mentors in the industry about 3D printed jig fixtures and on-demand manufacturing of these fixtures. This is a part one of these webinar series. We'll be having part two as well, with one of a leading, there is going to be a keynote speaker. He's from one of the leading fixture manufacturing company in India. So, as I really appreciate the fact that you could have invested this time that you are investing here with me and with Divide by Zero, keeping that trust, and I'll try and bring as much value as I can from my side, ensuring, and valuing your time. So if you have any questions, if you want to know anything, keep your questions parked in Q&A section so that I can take them up later on. And let's start quickly. So briefly about, quickly about Divide by Zero, and we'll move ahead. So jig fixtures, basically, you all know about jig fixtures, and you must be, having this idea about these kind of tools that are being used in manufacturing. Fixtures are basically holding mechanisms for various operations like drilling, milling, measurement, or even testing or assembly. And jigs are basically tool guiding, basically mechanisms which are being used for, say, particular operation, wherein it's either drilling or holding, and the guide tool. Fixtures do not guide tools. Various fixtures applications we have seen, and they are beyond the list here. And we've been part of many such application support. When our customers needed it, may it be assembling electronic components and even PCB fixtures, which are not mentioned here, or may it be electromechanical sensor mounting and assembly fixtures. So there can be various applications and various types of fixtures, but today we are going to talk about these fixtures and how we can make these fixtures using 3D printing, especially polymer 3D printing, and how it can help in small batch manufacturing and even long-term continuous manufacturing, both the areas we will be looking into. So typically, when we talk about any manufacturing process, or for that matter, if we look at fixture manufacturing process, it's done using two technologies, either subtractive or additive. And mostly we have seen subtractive. We are not using formative or injection molding for fixtures, but CNC machining. And there's another method that we can do is 3D printing. Before we go further, this is a typical graph wherein you can see cost per part in the left-hand side and quantity on the right-hand side, wherein if you see the cost, of additive manufacturing between 0 to 100 and 0 to 1000 components. It's not varying much, but you can see a huge change here in you know formative technology or even subtractive technology. So if you need 50 or 100 parts, 150 components, you have tooling costs even for subtractive manufacturing. You need to have a setup, a blank size or a block of wood or plastic or metal to be able to cut it through in CNC machining. And in formative as well, there is a tooling cost. But but additive manufacturing, however, the cost is constant. This zone of 1 to 150 components on an average, which our study and a lot of studies that we have followed in industry we have seen, talks about is where 3D printing can be game changer, and it can support small batch manufacturing. Fixtures typically fall into this area wherein you have you are making one of two of fixtures, and every component on these fixtures is unique by design. And when you have such small batches of components to make, additive manufacturing can be game changer if at all you can print and make components as accurate as CNC machine components, as strong as CNC, and maybe and as durable as the traditional fixtures which are available in the market. I would quickly like to understand, how many of you have accessed 3D printer or tried 3D printing services, just to know, because, based on that, we can, decide on how deep we have to go onto this 3D printing, explaining 3D printing and all here. So can we have the poll, please, Shruti? Yeah, so I want your support here. I just wanted to understand, if you own a 3D printer, how many of you have outsourced for 3D printing services? How many of you are new to the technology? We've got amazing audience here. Such a quick response, and everybody's contributing. Okay, we have almost a tie, I guess. We'll just wait for a few more seconds. Wow, so many people, you already own 3D printers and you're outsourcing as well. Okay. Okay, great. So can we have the results, please, Shruti? Okay, so almost 30% of you own a 3D printer. That's amazing. 33% of you have outsourced 3D printing services, so you have experienced 3D printing, and 37% of us here today are new to the technology. So guys, just hold on. I know you might be having a lot of detailed questions, and I'll ensure I answer all of them. But let me go in the depth of slightly in terms of 3D printing and how it works quickly. So yep. Okay, so this is a typical process of 3D printing wherein you have, you start with a 3D CAD model, and you, just like CNC, you have, you have CAM, you have a slicing software here which generates a G code, and so maybe you have a 3D design here, which you want to load into your machine, and this is a time lapse video of one of our printing this component. So this is a fast forwarded one. And then a printer prints these components layer by layer by extruding polymer, and these kind of components are ready to make. If you want to make these kind of a component that you can see in this video, it would take a lot of tool change, a lot of different tools altogether on a CNC machine. But with a 3D printer, you can make complex geometries and components much faster. And in terms of 3D printing, I'll just quickly run through here. Is that large amount of applications, or maybe 3D printing is used in automobile industry, and then you have consumer goods, medical, aerospace, and other industries as well. But it's very aggressively utilized by automobile industry, and nowadays there are other industries and startups coming up, and then again there is segmentation in terms of EV and IC engine and all these kind of industries. But usually this is the picture. But automobile industry has huge requirements of fixturing as well as aerospace, and now we see some of the other industries also applying 3D printing and fixturing as well. So many of you, I think, you have already used, or you've been traditionally utilizing fixtures in your assembly line, or you've worked with fixtures. So, for you, I just wanted to understand what is your biggest challenge in sourcing fixtures for your requirement. So if you need a fixture, what is your biggest challenge that you have? Is it time? Is it cost? Or is it repair, replacement timeline, or any other issue that you face? We can quickly have a poll on this. So what is the biggest challenge that you have? I mean, in terms of sourcing these fixtures from vendors or getting these fixtures made. Because what we have seen is for various other different customers, it's a different problem. For the ones who are clicking on others, if you could quickly put it on the chat box, what is that other that you have? So that also gives us some insights. So if you could put into the chat what is the other challenge that you face when you're sourcing fixtures for your requirements or for your applications. Okay, great. We have around 100% of people who have basically, casted the vote. So we have, time is one of the major factor here, which is the biggest challenge I can see. Then there is cost, and there is repair maintenance timeline as well, and there is other. I've not seen the other reasons here, but yes, designing a suitable fixture for 3D printing. Okay, Sriram, we'll get into that. Nice, seeing you here. Okay. Yes. So multiple vendors and other questions. We'll take that up as well. But that's really great. So yes, it's usually timeline because of the outsourced processes that you have. It's also cost because it's outsourced, and these are one of two of fixtures, and making these fixtures on a traditional CNC or other setups would take a lot of setup time, a lot of tooling, even sometimes fixtures components, if they are complicated and they have undercuts, you need some more fixtures to hold these components as well. So fixture development requiring fixturing as well, so that also adds up to your cost. Repair replacement is a big pain because if these fixtures are on an assembly line where you're churning out continuous manufacturing, and one of the fixtures goes bad, you have a lot on stake. So you need repair replacement as fast as possible. And we've seen many other issues. Some of them here are multiple vendors, multiple materials. Some of the components cannot be designed, and maybe can't be handled through traditional processes. But yes, we'll be looking at a generalized solutions here and generalized applications on this in this webinar. But we can take up your one-to-one questions specific to your requirement, specific to your problem, on a link that will be shared by one of my team members, so that we can set up a one-to-one call with you and understand your issues as well. So typically we had worked with one of the companies for automotive basically lamp assembly fixtures, and wherein we could help them work on these fixtures. The black components here that you see in this presentation, they are the molded lamp assemblies, and the green and blue components that you see are 3D printed components. And so traditionally, it used to take around 40-45 days for them to get these fixtures made from their vendor. And with the honor with the 3D printing, our solutions, we could deliver these in 2 days. And there is huge time and cost saving. There were a lot of challenges. These were the first iterations of the fixtures that we developed. But beyond that, they further wanted to save on cost. They further wanted to also check what are the number of cycles these fixtures can run on. And we could do this extensive study. We could understand that these fixtures could run on around 200 to 300K cycles for assembly. But then further to that, there was certain material changes that were done. There were certain process changes also added, which could make these fixtures last for 800 to 700K cycles, which is equivalent to what they were expecting as a customer. So, I'll just quickly run through the video of the assembly line where these fixtures were, also used. So all these blue and green components that we see here are 3D printed, and they are some designs usually deliver around 700 such fixtures for our customers' application. So this was the initial journey when we started with these fixtures, and then it went ahead for on welding fixtures or assembly and other fixtures also. So this was one of the applications wherein one of our customers, they needed pipe welding fixtures for initially just stack welding so that they have a placement of these kind of tubes right, and we could help them with these kind of 3D printed fixtures with certain metal inserts in between, which hold these tubes together. And also there was a metal padding provided if in case there is some spatter or there is some welding spatter is coming out. But then again, so this was one such application where in specific, this was actually a one section of that fixture, but this was a huge one wherein you have various joints and complex components coming together. Traditionally, it took around 10 days for them to develop these kind of fixturing, and then with Eon, we could do it in this in around 2 days. Huge saving here around 8 to 10 days, and in the cost as well. This was around length of 223 by 300 by 50 mm. Here again, in this kind of application, when you have even if you have trial fixtures, because welding again involves a lot of heat and processing. So in many cases, also trial fixtures were developed. And in some of the cases wherein you have just initial type of joint replacements, holding, or even spot welding fixtures, they can be developed using 3D printing. And for this we could use traditionally, we initially started with ABS, and we also went ahead on high temperature materials and also coated this with spatterproof coat on the surface. So this was one such application. Not only that, in terms of tubes and tube bending, you have different profiles and angles, and this is the profiles, they need to be checked. And usually for tube bending, it's very critical and crucial before any such component goes on the assembly or welding as well. And this is very, very critical, wherein these fixtures can be quickly made out of a 3D printer and deployed. And this was one such application wherein we could do a lot of time cost saving for customers. Another great part here is because these fixtures can be developed at such a low cost, even for initial trials and checking quality of small batch, these kind of fixtures can play a big role. And even the customer could appreciate the fact that this was something which was implemented even for a small batch, and this was something we could support with them here with, again, huge time and cost saving for them, around 80-85%. Typically, in terms of fixtures, we are just holding components all together, but with the jigs, we could initially also develop certain jigs, which are drilling jigs, and there are many other fixtures and jigs that we have developed. But because of the non-disclosure that we signed with these companies and intellectual property and other issues, we could not show everything here. But as I mentioned, this was a small again jig wherein we use a gunmetal bush just for supporting or holding the drill all together, and the rest of the jig was 3D printed. And for drilling the jig, drilling ball drilling, basically. Again, this is a small jig to hold that particular component for that particular application. But that's a possibility here. You can also see typically, masking fixtures, so wherein you need to have these kind of decals, which are being put on automobile, on stickers, and on different, products that you make, and sometimes they're not aligned, or if it takes a lot of time to align these kind of stickers or labels. So it is, these kind of masking fixtures were also developed for a lot of automobile companies from our end, and even this is one of our machines wherein we have actually implemented this kind of a fixture, so which holds gives you a reference of exact reference of where you can place this decal and directly go ahead with that. So that is also an advantage. Not only this, there are instances wherein we have developed laser marking fixtures, wherein you have identification numbers running through your system and a laser marking machine, putting these identification numbers on the, on the go on these kind of on smaller or bigger components. And there, these components need to be held in a particular way, in particular angle. And these kind of fixtures also are developed for, serial number marking and so on and so forth. But there is a huge time and cost saving. I'll explain why this time and cost saving is there. This is another example wherein we could help one of the largest, large American automotive manufacturer, located in down south Chennai, wherein they were making these kind of tools, which were holding, I would say, a component or a fixture um, to assemble the engine altogether. And they were making it in 14 different parts, and their traditional timeline was around 9 weeks. We could deliver this in a week's time with around with one of our internal engineers support. He could redesign this and make it into two different parts, and that was a game changer again. And with this complete tool, these are the two tools that were designed by our engineer. And then this was, basically, this was taking a point load of around 400 kg with the mounted engine, and this is something that you can see here. So these kind of basically tool manufacturing or fixturing is also possible for small batch or even sometimes high-end continuous manufacturing. I would like to show some of these components or fixtures on a live setup. Let me just turn on my camera. Okay. So this is so this is one of the fixtures that I have here on my desk, and wherein you can see this is again, this is a representation, but this is the tube which is being fit here, and these silver components here are metal pieces. Okay, and you can, this is a typical welding or fixture for especially tube welding and for precision welding, such kind of applications. So you can have, so these, the silver ones are metal inserts here, so they can be made, and this is completely 3D printed and single body component here. Another one that I have here is the ball drilling jig here. So this has a platform wherein you can hold the ball, and through this there are two basically insert which are holding this together, and then on top we have a gunmetal insert which goes through here, and which holds, and through which basically which guides the drill bit. And this is also one of such fixtures we have. This was the basically masking fixture that we were talking about, okay, which can have a handle and you can easily hold it, and then you can have a particular the sticker coming up with this reference on the line. So this is one such example. And also I was talking about a profile, check fixture, wherein you just have this kind of fixture to check the profile of the bent tube, and if it is okay or not okay. It's kind of a gauge as well. You can use it, go no go, and that's something we have. So these are some of the applications out of many such applications that we had developed. But one question we always got, while working on these fixtures, is that how durable or how what kind of load these kind of fixtures take, and how durable these fixtures are when they are made out of 3D printed. Basically, when they're 3D printed and made out of these machines. So how strong these parts can be. So one example or one parallel that I would like to draw here and show you one such example, that choosing right technology with right material and right parameters is very, very important and crucial for any application development. And as Divide by Zero, we, more than being a machine manufacturer, we are a solution provider and application experts here. who know, in terms of with our internal team, with our polymer development team and an application team, we have worked on various such applications and developed materials, parameters, and profiles, and in terms of even application development. So quickly, let me show you how strong these parts can be. We were also able to develop sheet metal forming tools using 3D printed materials for some of the applications, and these tools could last from 200 to 2000 bends. And these were sheet metal forming tools, and punch and dies were developed. Let me just quickly show you the video here. So again, when we talk about these kind of press brake, or even short draw tools which are developed using polycarbonate or glass fill or carbon fiber filled materials, or even other engineering grade materials that our machines can work with, this is something which is very important. As I mentioned, we've been working on the second part of this webinar as well, where we are going to talk about many in-depth applications and more possibilities with materials. And also, we're going to talk about one of the next generation machines that we have already launched, which is very, very crucial for development of these fixtures, which has capability of additive and subtractive manufacturing both. This part two of this webinar is going to be, in coming few weeks. And our keynote speaker is going to be Mr. Kedar Nandargi. He's CEO at Unique Circle, which is one of the largest fixture manufacturing companies in India. They are and India and abroad as well. They're one of the exporters as well. So we have developed certain unique fixtures and a lot of applications with them, and we're going to discuss about that as well. So we'll keep you all posted on the second part as well, and and the invitations will come through. But that is coming, and that is also going to be a game changer webinar, I'm sure. So why 3D printed jig fixtures? One reason that we have seen is they are very easy to handle, and they are up to 60% lesser, in weight. So they're lighter. Maybe wherein you needed 2 or 3 people when you had metal fixtures, now you just need a one person to handle these fixtures. So they're lightweight. This is one major reason. Secondly, we see a lot of better component handling. We can also top these fixtures up with one of the, maybe one of the creatives that our team made, wherein you can see the TPU, polyurethane top with a so softer surface area, wherein the component is coming in contact with the fixture, and the harder material wherein you need strength. So these kind of dual layer sandwich fixtures also can be made so that you don't have scratches on the part, or better handling the rejection. It's reduced because of the metallic fixtures. Again, I can see a lot of you here, but if you have any questions, I would want you to park these questions in Q&A. I would love to take these questions and answer your questions on one-on-one basis. Not like every time we'll be able to give all the details, but then some of the details can come out really well if you ask questions. So I would encourage all of you all to ask your questions. Yeah, and time and cost saving, yes, huge, up to 90%. And why there is time and cost saving? Reason behind is, if at all you are making these fixtures, even though you're making this in-house with a CNC machine, or you are making these fixtures, getting it done from vendor, they require a lot of tool changes. They require to work on CAM programming for strategies, different tools. Even as I said, if you have a complex geometry, you need fixturing for fixturing. So to hold these components and machine them out from different angles and different sides. So that takes a lot of time. With 3D printing, it's much, much faster and very, very cost effective as well. And yes, as I said, huge cost saving here with various materials and possible solutions on this. Uh, Also, we have seen in many cases, if you have design alterations and even if you have failures or any changes, or if you want to repair any particular fixture where one of the component has gone bad, you can reprint the fixture in few hours rather than waiting for your vendor to deliver the fixture in weeks. So that's something which is a complete game changer for the uh, the users of this technology. Beyond that, what more is possible is we have seen some of our customers setting up their design studios in Pune and having their customers in Chennai, Bangalore, and Delhi, Noida. And these companies, when they need a particular component, so typically they have a validation process which is done every 3 months or monthly basis, depending on the criticality of the component and the fixture. But if any fixture runs out or any component goes bad out of these fixtures, or if they needs repair and particular component needs replacement, their customers have installed 3D printers and they have all the designs loaded into these machines. So within few hours, they can actually print that component and start the assembly line without any delay. So that's a power of 3D printing and distributed manufacturing. Typically, you will have material. So you place an order to your vendor. That vendor will source the material, and then they'll take for manufacturing, machining, and then it will be assembled back and then delivered through distribution channels, or maybe shipped to you. And it takes a lot of time, and also that involves a lot of cost on the assembly line. So this is much faster. So this approach has helped many of the companies. In fact, we have seen one of the companies that had implemented this, and one of the main I would say change maker, the guy who the person who actually worked on this with us and invested into this technology was promoted back to back twice in their organization. Beyond this, these kind of fixtures, they cannot be printed with typical traditional FDM machines. They need high strength engineering materials. So typically, we have carbon fiber materials, which are PET based carbon fiber, nylon based carbon fiber. Certain areas you can also use PLA based carbon fiber for initial testing and trial fixtures. We have two grades of nylon material which is coming in, which is either nylon 6 and nylon 12. PCPBT, polypropylene 3D printing is also possible. It's in beta right now. We can do parts up to 150 cube, but we're also testing large parts right now. And polycarbonate is one of the game changer materials that we see for the fixturing industry. So this is something which is very crucial. Choosing right material for right application, right orientation, and right print parameters are key to success in especially fixturing or jig handling when it comes to 3D printing. In this journey, we did develop one of the technology pieces which could deliver higher strength when compared to traditional 3D printing or traditional technologies that are available, which is called AFPM, which is Advanced Fusion Plastic Modeling, and this is India's first 3D printing technology, which is patented in India and in the US. So this is an amalgamation of 3D printing, material engineering, and software development all together, which delivers much higher strength in terms of DM components and at much lesser cost. So typically with the STM D638, we also have material that can hit up to 110 MPa right now with much lesser cost compared to typical SLS, SLA, or FDM processes. And as I said, we have India and US patents for this technology that is being developed, and because of which we are also exporting these machines for such end-use applications. While working on this, we could also, we also knew that 3D printing somewhere down the line is slow, and it needs to, something needs to be done in that area, because typical deposition rates of these machines is around 10 to 15 cubic centimeter per hour. And by that speed, many of the small batch manufacturing or fixturing applications cannot be delivered on time. And we could work on certain development in terms of machine and complete redoing the complete infrastructure of the machine, print engine, So wherein we developed Eon 500 MK3, which has deposition rate of around 100 to 150 cubic centimeter, and it's pretty aggressive. Not only this machine can deliver faster parts up to 10 times faster than traditional FDM machines, but it can also deliver accurate and parts with greater surface finish for your end use application. So this is a small batch manufacturing machine, especially that we have developed. As I mentioned with that graph, we are focused on the small batch manufacturing area, and we want to see what value we can bring in when we empower MSMEs, SMEs, and even large companies. Everybody needs a small batch manufacturing, and we bring that change with 3D printing. These are some of our customers, and we have 800 plus installation across India and across the world now. So right from Daimler, Mercedes to Kirloskar, Unilever, these are some of our customers, prestigious customers that we have. But real power or real support system for us are these, institutes wherein we have worked with, many IITs or Anna University, KV, and many other institutions wherein we have, with some of these, we have joint development program MOUs wherein they support us for our material development, software development, and application development as well. So, these institutes or organizations have major role in our success, sure. These are some of the machines that we have: AccuCraft series, Icon, Eon, and Eon MK3, from our Studio series to a desktop industrial printer to industrial large format machines that we have. What sets these machines apart is typically when you are running these machines in an environment wherein you want to have continuous small batch manufacturing, you want to ensure these machines are running continuously without failed prints. So we have also implemented with the newer Eon machines automatic switchover mechanism, which can switch over, which can basically detect the clog, predict the clog, and switch over to secondary extruder. And this is basically a hardware upgrade that we have delivered into this, which can predict the clog and switch over, so that if at all there is a clog, many of you who are using 3D printers, you must be witnessing that your machines are running in the air and either they cannot do anything. But just like aeroplanes have secondary pneumatic hydraulic system, we have a secondary head here which can switch over to secondary and continuously ensure the print is done next day morning when you see the print. Not only that, these machines have, as I said, automatic power resume. They can switch over the print. They have servo extruders. In fact, MK3 is all servo and all ball screw machine for high speed printing, and they can reach extruder temperature up to 450 degrees. And we have stable build platform and moving gantries on, this kind of machines. So I understand that you all must have different applications, different requirements, and different problems to solve. And not all the problems could be solved, but some of the ideas you must have got from the application webinar that, or the data that I showed you here. So what we can do is we can, set up a one-to-one call if you have such requirement, if you want to understand, if you want to solve a particular problem and you want us to help you there. We are ready. We are as well committed to solve that, and we want to add value here. So we can sit with you. Our application team can sit with you. You agree a time slot according to your calendar. You can select that, and you provide the design samples and application details. And we can also help you out and help you, give you a free sampling for, in first 15 applicants up to 150 cubic centimeter. So my team will be sharing a link here. You can just fill up the form quickly, and you can take advantage of this offer basically. I'd like to take up any questions if you have quickly and answer this. Rohit, is it possible in FDM printer which material can do this? Okay, so Rohit, basically you can do this in FDM with better accuracy, and you can do this with materials like nylon 6, nylon 12, polycarbonate, and so on and so forth. So you need such materials for this. Okay. Infill analysis, I don't understand this question, but I think you're asking for the infill. So typically these are at 100%. Okay, so 3D printer sizes, you can have smallest build size, from 6 inch to, you even have 3 meter cube 3D printers available, Sanjay, on the market. So printer size is no bar these days. But yeah, if you have a particular application wherein you want to discuss, we'll be happy to connect with you and answer this on one-to-one. Okay. Okay, David. Mr. David is asking, hello. Thank you for amazing webinar. Okay, thank you. Yeah, you're welcome. In case a job requires multiple side machining, would it be possible to develop swiveling fixture? Yes, it's possible. I think you can share the design or the details with us, and we'll be happy to support you. We have done this kind of work before, and we can support you, David. Okay, we have. Okay, so Manish, you have an amazing question. How to get smooth and fine surface. So for that, you'll have to wait till our next webinar. We have one surprise coming your way. There is a machine that can print and automatically finish all these sides and components for you. And they can, basically, you'll have completely smooth finish out of these, that machine. Maybe let me just show you one of the components that I have here. I hope you can see this. This is from that particular machine. So this component is built from that particular machine, which can do 3D printing and CNC milling. I'm not sure if I should be saying it here or not, but in one machine. And we are coming up, and we've actually developed this machine for fixturing application. So this is going to be game changer. So we'll come up with that. You stay tuned for our next webinar. I'll just quickly go back to my slide. Okay. What other questions we have? Let me check. Okay, we have. Is it possible to design PET bottle for packaging fruit beverage? Yes, and we have also developed small batch blow mold tools as well, using this newer technology that we're talking about, and we were able to work on this. So this is also possible. We can talk definitely. Bhavandeep ji, we would love to talk to you on one-on-one basis. You can just select a time slot in the link, and let us know when you're free, and we will be happy to talk to you. Okay. Sure, Viraj. We would, my team would get in touch with you, and we'd be happy to know you have already, your own machine, and you want to know more about some of the new features. So yes, we can talk. Okay. Yes, so we have a machine that is coming up which can print and even post process on the go. So Arun Kumarji, that is coming up. We need to catch up soon in Chennai. So then this is something which is coming up and which is new. And for that, we have the next webinar wherein we're talking about this, and which is specially for the fixturing industry. So we'll be taking that up. And okay. Okay, we also have some questions in chat. Let me see. Whether you have a branch in Madurai? No, we have a branch. We have people in Chennai, and we have people in Coimbatore, but not in Madurai, that we can check. Yes, we have many companies who are into foundry, who use, these companies use our machines for making patterns, even core boxes for sand core boxes, for sand cores, and this can be used there. Okay. So Gokul Krishnanji, we can get in touch one-to-one, and you can, we can discuss about the sheet metal bending fixturing, and maybe we can share the link as well with you. Maybe you can get in touch, and you can share your time slot, and we can connect on one-on-one basis. Yes, I guess that's it. If you have any more questions, if you want to know more, we can Yes, there's, I guess, our team can share with you in terms of information on foundry patterns. And here you go, Mr. Ayappa. You have my email address. And thank you all. Thank you, everyone, for joining in today. I hope this session was helpful. And if you want to know more for about any particular uh, application, or if you have any specific requirement, we will be happy to connect with you on one-on-one call. A link has been shared with, by my team here, and this can be taken up quickly, and we'll take it up. In the meanwhile, you can also go back and share your feedback on this webinar, how you liked it, what all, more things you want us to cover, or anything which is, required from you. And we also have shared one LinkedIn link wherein we had posted this webinar. So if you think this webinar was helpful, you could just go back and comment on that link on LinkedIn, so that other people or other industry folks also know that this webinar added value. I really thank you all for your time and your commitment here. I hope I was able to add value here. Thank you once again, and see you soon for the next session.